Nuclear energy. Nuclear power is produced by nuclear fission, which involves splitting the heavy atomic nuclei, mainly uranium-235 and plutonium-239, to produce vast amounts of energy based on the mass-energy equivalence equation. Fuel resources. Uranium. Uranium, the major nuclear fuel, specifically the U-235 isotope, that is made of only 0.7% of natural uranium. Thorium, a possible nuclear fuel that may have the following benefits. It is more common and has fewer radioactive emissions. Plutonium, neutron capture of U-38 in nuclear reactors, breeder reactors and nuclear weapons. Key uranium producing nations. The three countries, Kazakhstan, Canada and Australia, account for over 63% of the world's production of uranium. Other major producers are Namibia, Nigeria, Russia and Uzbekistan. India has vast thorium deposits estimated to make 1/4 of the world's deposits, mainly monazite sands along the coast. Non-conventional energy resources. The non-conventional sources of energy or renewable or alternate source of energy are the ones that are generated through natural processes that are being replenished all the time. These sources provide alternative sources of fossil fuels that have little environmental degradation and emission of greenhouse gases. Solar energy. Solar energy uses the electromagnetic radiation of the sun in the production of heat and electricity. In the case of solar energy, the sun contributes about 1,73,000 tetrawatt of energy to the surface of the earth, which is an unlimited source of energy. Solar energy harnesses technologies. Solar thermal systems use solar collectors to heat water or air to be used in domestic and industrial purposes. Concentrated solar power. This one makes use of mirrors or lenses to focus sunlight on a large scale to produce power. Geographical distribution and potential. Areas within the solar belt within 40 degrees north to 40 degrees south are the best for getting maximum solar radiation. There are countries such as India, Australia, portions of Africa, the Saharan region, Middle Eastern countries, the southwestern parts of USA and Central Asia that have great potential for solar energy. The theoretical solar power capacity in India is more than 5,000 trillion kilowatt hours per year. Uses and benefits. Solar power is employed in the production of electricity, heating of water, drying of crops, cooking, solar cookers, desalination of water and to energize remote communication networks. Pros are plenty, no fuel expenses, capacity to generate in a distributed manner, low maintenance, ability to scale to very small rooftop installation to large scale solar farms and zero emission of operations. Wind energy. Wind energy uses the kinetic energy of moving air masses which are induced due to difference in heating of the surface of the earth, the rotation of the earth and the topography. This kinetic energy is then transformed by the wind turbines into mechanical power and then into electricity. Factors that affect wind energy. Wind velocity and reliability. Regions where the average wind velocity is over 5 meters per second can be used. Topography, mountain passes, plain coastal areas, the wind patterns of the seasons and land and accessibility to transmission infrastructure. Key wind energy areas. Coastal areas, mountainous passes and open plains present the best areas in which wind energy can be developed. China, the United States, Germany, India, Spain and the United Kingdoms are major wind energy producers. The fastest growing segment is represented by the offshore wind farms in the Northern Sea, Baltic Sea and Atlantic coasts. Hydroelectric power. Hydroelectric power transforms the potential power of water held at elevations into kinetic energy and then into electrical energy, utilizing turbines and generators. It is the oldest and most established source of renewable energy. Projects of hydroelectric projects. Storage, reservoirs, projects. Mammoth dams that form reservoirs to regulate water discharge and generation of powers. Run-of-river projects use the natural flow of rivers with no significant storage. Pumped storage projects. This is where energy is stored by pumping water to higher reservoirs when the demand is low. Biomass energy. Biomass energy is based on organic substances such as agricultural waste, forest waste, animal waste, urban waste and energy crops. It is a renewable resource that is carbon neutral and sustainable. Sources of biomass. Agricultural residues, crop stalks, husks, shell bagasse. Forest residues, sawdust, forest chips and logging waste. Waste of animals, cattle dung, poultry litter. Energy crops, jatropha, sweet sorghum, switchgrass and miscanthus. Urban waste, urban solid waste sewerage. Significance. Biomass energy is a decentralized rural energy supply. Farm wastes are reduced and organic fertilizers like biogas slurry are produced and it provides rural employment as well as renewable transportation fuel. The National Biogas and Manure Management Program in India has installed more than 5 million biogas systems benefiting the rural households. Geothermal energy. Geothermal energy makes use of heat that is stored in interior part of earth and is mainly produced by radioactive decay of minerals and leftover heat created during the formation of the earth. The temperature rises at a rate of 30 to 25 degrees centigrade per kilometer geothermal gradient. Geothermal resources. Hydrothermal system. A pool of hot water or steam natural in geologically active regions. Geopressured resources. Deep oil and gas reserves are deposited in the hot water in the deep sedimentary basins. Hot dry rock. Geothermal systems have been further developed to need hydraulic fracturing to form man-made reservoirs. Magma. Resources of the highest temperature that need sophisticated technology. Geographical distribution. Geothermal distribution are found in the boundaries of tectonic plates and especially the ring of fire that surrounds the Pacific Ocean. Iceland, New Zealand, Philippines, Indonesia, Kenya, the United States, California, Nevada. Italy and Japan has largest geothermal installations. The potentials of India are in the Himalayan region, the Cambay Basin and the thermal springs in Jharkhand and Chhattisgarh. Tidal and ocean energy. Ocean energy includes tidal energy due to the attraction of the moon and the sun, wave energy powered by wind blowing on the surface, ocean thermal energy conversion powered by temperature differences, and salinity gradient energy that is osmotic power. Tidal energy. Tidal energy takes advantage of the predictability of the rise and fall of the ocean water due to the gravitational interaction. The energy is formed tidal barrages, tidal stream generators and dynamic tidal power systems. Appropriate site must have a tidal range that is greater than 5 meters and suitable coastal geology. Wave energy. Waves that are found in the oceans have a lot of kinetic and potential energy. Wave motion is transformed into electricity using different technologies such as oscillating water columns, point observers and overtop devices to name a few. The coastal areas of steady waves have a potential, but technology has yet to be developed. Ocean thermal energy conversion. OTEC utilizes temperature differences between hot and cold water in the oceans. Tropical ocean waters are 25 degrees to 5 degrees of the tropics. It is an experimental technology that could be adopted in the tropical island countries and along coastlines.